When you enter the Kennedy Space Center, your attention is immediately drawn to the rocket garden. Rockets that pioneered America's space exploration are displayed so that you can see them close up and learn about their use in the NASA space program. Some rockets launch satellites that circle the Earth and the Moon or sent probes into our solar system and beyond. Others put astronauts in space as part of NASA's program that landed humans on the Moon and brought them back home safely. The Juno 1's most significant flight launched America's first satellite, Explorer 1, into orbit. Explorer 1 detected vast layers of energy-emitting particles that were named the Van Allen belts. A Juno 2 rocket sent Pioneer 4 past the Moon and into orbit around the Sun, sending back a huge cache of information, marking the beginning of the Deep Space Network. The Delta rocket's exceptional reliability made it the launch vehicle of choice for many of the most significant early-year launches, highlighted by its launch of Telstar, the satellite that relayed intercontinental television signals in real time, making world events available on your TV as they happened. The Atlas Agena launch vehicle paired an Atlas rocket with an Agena upper stage that launched 109 times between 1960 and 1978, with notable launches including the first 5 Mariner probes to Venus and Mars, 9 Ranger probes to photograph the Moon, 1 target vehicle for docking practice with Gemini crewed spacecraft, and 5 lunar orbiter spacecraft that helped select Apollo landing sites by mapping the Moon's surface. The Delta II launched 155 times over its 29-year history that featured orbiting the first global positioning system and vital commercial communications and imaging satellites, and sending the Spirit and Opportunity rovers to Mars. The Mercury Redstone rocket launched 6 suborbital Mercury space vehicle flights that enabled NASA to evaluate the performance aspects of the Mercury spacecraft, the effects of a weightless environment on astronauts, and the launch and recovery operations at Kennedy Space Center. Mercury Redstone launch vehicles made Alan Shepard the first U.S. astronaut in space during a suborbital flight on May 5, 1961, and Gus Grissom the second on July 21, 1961. The Mercury Atlas mission objective was to place a man into Earth orbit, observe his reaction to space environment, and safely return him to Earth. On February 20, 1962, an Atlas rocket launched the Mercury capsule Friendship 7, flown by John Glenn, into 3 Earth orbits, making Glenn the first American to orbit the Earth. The Titan II medium-lift space vehicle launched all 12 Gemini missions that developed procedures to navigate, rendezvous, and dock in space, and demonstrated extravehicular activity, spacewalks, developing the skills and systems needed to get to the Moon and back. NASA used the Saturn 1B launch vehicle to launch the unmanned Apollo 5, the 3-manned Apollo 7, all 3 Skylab crews, and the Apollo-Soyuz test project into orbit, and was the primary vehicle for a canceled Skylab 5 mission. By sharing the S-4B upper stage, the Saturn 1B and Saturn 5 provided a common interface to the Apollo spacecraft. Early launch failures demonstrated the need to hold bigger rockets on the platform until the liquid-fueled engines could build up enough thrust to safely lift off. This hold-down arm is one of 8 of these devices, one under each of the Saturn 1B's fins, that held the giant rocket in place during these critical seconds. The Saturn V was developed as the launch vehicle for lunar missions in the Apollo program. At the time, it was the world's largest and most powerful space launch vehicle, employing 41 separate engines to carry the Apollo command and service modules into Earth orbit and then onto the Moon. It launched 1 Skylab and 12 Apollo missions. The F-1 engine is the most powerful liquid-fueled rocket engine ever produced and was a critical component in sending astronauts to the moon during the Apollo program. It required a cluster of 5 F-1 engines generating more than 7.5 million pounds of thrust to lift the rocket off the pad. The first stage of the Saturn V rocket burned for about 2.5 minutes and lifted the vehicle and payload to an altitude of 38 miles, traveling at 6,000 miles per hour. The center engine was fixed in position, while the 4 outer engines could be hydraulically gimbaled to control the rocket. 5 J2 engines powered the second stage with a combined thrust of 1 million pounds. It burned for approximately 6 minutes, taking the vehicle and payload to an altitude of 115 miles, 935 miles downrange, and a 15,500 mile per hour velocity. The third stage had 1 J2 engine that burned for 2.75 minutes with a 200,000-pound thrust that boosted the spacecraft to an orbital velocity of 17,500 miles per hour. After 2 or 3 orbits, the engine was reignited and propelled the spacecraft into a translunar trajectory that took the command and service modules to the moon. The command and service module functioned as a mothership, carting 3 astronauts and the Apollo lunar module to lunar orbit and brought the astronauts back to Earth after discarding the lunar lander.
Once the spacecraft was traveling from Earth heading toward the moon, the astronauts needed to pull off a mid-flight maneuver to reconfigure the ship so the crew could access the lunar module, which was stored inside the third stage during launch. To do this, the panels of the lunar module adapter were jettisoned, and the reaction control thrusters of the command service module were fired to separate it from the third stage. The command service module thruster then rotated the command service module by 180 degrees, maneuvering to dock with the lunar module and extract it from the rocket. This all took place while hurtling through space at more than 24,000 miles per hour. The lunar module, now docked with the command service module mothership, was now ready for its 3-day journey to the moon.
The Apollo lunar module was the spacecraft flown between lunar orbit and the moon's surface during the Apollo program. The 2-stage lunar module was ferried in lunar orbit attached to the Apollo command and service modules. Its crew of 2 flew the complete lunar module from lunar orbit to the moon's surface. During takeoff from the moon, the spent descent stage was used as a launch pad for the ascent stage, which then flew back to the command module, after which it was discarded.
Only seconds left for success. 1,300 feet above the moon's surface, Neil Armstrong and Buzz Aldrin began their final descent in the lunar module Eagle when they realized they had overshot the predicted landing zone by 3.5 miles. Eagle was running out of fuel and heading straight for a gaping lunar crater filled with large boulders. Armstrong made the decision to take control and fly manually, burning extra fuel while searching for a safe place to land. Normally expected to land with about 2 minutes of fuel remaining, the ship was still 100 feet above the surface when a warning light indicated there was 60 seconds of fuel remaining. They were about 10 feet from the surface when another alarm indicated they were down to a critical 30 seconds of fuel. Moments later, the craft settled onto the lunar surface 4 miles from the planned landing site, with about 20 seconds of fuel remaining. Houston, Tranquility Base here. The Eagle has landed.
The astronauts spent most of their time in the command module, which was the only section of the spacecraft designed to return to Earth intact. The service module is jettisoned just before re-entry. The launch escape system would be used in an emergency to quickly separate the capsule from the launch vehicle and take it a safe distance from the launch pad, at which time the capsule's parachute recovery system would safely land it where it can be easily recovered. Apollo 7 was an Earth orbital mission to thoroughly test the systems of the Apollo command and service modules and included the first television broadcast from space. Apollo 8 was the first crewed spacecraft to escape Earth's gravity. It orbited the Moon 10 times without landing and returned safely back to Earth. Apollo 9 was the first crewed flight with all of the Apollo lunar hardware and carried out a full test of the lunar landing module while in Earth's orbit. The Apollo 10 mission evaluated the crew's, space vehicle, and mission support facilities' performance during a piloted lunar mission, but did not land on the Moon. The Apollo 11 mission achieved the Apollo program's goal to perform a piloted lunar landing, walk on the Moon, and return safely to Earth.
After launch and the jettison of the first and second stages of the Saturn V, the third stage fired its engine, putting the spacecraft into a parking orbit 118 miles above Earth, where final checks were made. The third stage then ignited again to put the craft on a path toward the Moon. For the next 3 days, the astronauts coasted 250,000 miles through space until they fired the engine for the lunar orbit insertion, putting them in orbit around the Moon. This is where the crew split up. Armstrong and Aldrin transferred to the lunar module and slowly descended to the surface, while Collins continued to orbit the Moon in the command module. After its mission on the lunar surface, the lunar module launched from the Moon, timing its ascent to rejoin the command service module in lunar orbit. Once Armstrong and Aldrin transferred back into the command module, the lunar module was released, and the command service module ignited its engine to perform the trans-Earth injection, breaking out of its lunar orbit to begin the journey back to Earth. When Apollo 11 reached its entry point in Earth's atmosphere, the service module was jettisoned, leaving only the command module to begin its re-entry back to Earth for splashdown in the Pacific Ocean.
The objectives of the Apollo 12 mission included an extensive series of lunar explorations and the deployment of the Apollo Lunar Surface Equipment Package that will gather seismic, scientific, and engineering data over a long period of time. Apollo 13 was supposed to land on the Moon, but an explosion on board forced it to circle the Moon without landing. In the end, Apollo 13 safely returned to the Earth, and NASA classified the mission as a successful failure because of the experience gained in rescuing the crew. Apollo 14's objectives included deploying the Apollo Lunar Surface Scientific Experiment Package, lunar field geology investigations, collecting surface material samples for return to Earth, and photographing surface details from an altitude of 60 nautical miles. The Apollo 14 command module, Kitty Hawk, was launched on January 31, 1971, and recovered from a successful Pacific Ocean splashdown on February 9, 1971. It is on loan from the Smithsonian. Apollo 15 was the first mission capable of a longer stay time on the Moon. The addition of the Lunar Roving Vehicle, or LRV, enhanced their exploration and geological investigations. The Lunar Roving Vehicle, LRV, was an electric vehicle that operated in the low-gravity vacuum of the Moon and traversed the lunar surface. One was used on each of the last 3 Apollo missions. Each LRV was carried to the Moon folded up in the lunar module's Quadrant 1 bay and driven an average of 30 kilometers without major incident, and they were left on the Moon. Apollo 16 added in-flight experiments and photographic tasks from lunar orbit with an ultraviolet stellar camera in spectral bands not seen from Earth. The Apollo 17 mission conducted the usual surface activities, performed in-flight experiments and photographic tasks during lunar orbit and trans-Earth coast. This was the last Apollo mission. This photo shows the Kennedy Space Center's firing room setup that included the actual consoles that were used for the Apollo launches. While seated in the theater, guests view a video that details the countdown and launch of the Apollo 8 mission. The astronaut transfer van was a NASA vehicle used at the Kennedy Space Center to transport astronauts from the operations and checkout building to the launch pad for missions and launch dress rehearsals. This is a mock-up of the Space Shuttle's external fuel tank with booster rockets. NASA's Space Shuttle fleet history began with the first launch on April 12, 1981. Starting with Columbia and continuing with Challenger, Discovery, Atlantis, and Endeavour, the spacecraft carried people into orbit repeatedly, launched, recovered, and repaired satellites, conducted cutting-edge research, and transported modules for the largest structure in space, the International Space Station. The final Space Shuttle mission ended July 21, 2011, when Atlantis rolled to a stop at its home port, NASA's Kennedy Space Flight Center. About the same size and weight as a DC-9 aircraft, the orbiter contained the pressurized crew compartment, which can normally carry up to 7 crew members, the huge cargo bay, and the 3 main engines mounted on its aft end. The cockpit, living quarters, and experiment operator stations are located in the forward fuselage of the orbiter vehicle. Payloads are carried in the mid-fuselage payload bay, and the orbiter's main engines and maneuvering thrusters are located in the aft fuselage. The Hubble, launched in 1990, is one of the largest and most versatile space telescopes. It captures extremely high-resolution images that led to many breakthroughs in astrophysics, such as determining the rate of the universe's expansion. The International Space Station was assembled and is maintained in low Earth orbit by a collaboration of 5 space agencies and their contractors. It is the largest space station ever built, and its primary purpose is to perform microgravity and space environment experiments. This Mars Rover Vehicle Navigator is a prototype electric vehicle designed for traversing the demanding landscape of Mars. It was designed under the consultation of NASA astronautics and the Kennedy Space Center Visitor Complex to inspire the next generation of space explorers. Dragon 1 was the original Dragon iteration that provided cargo service to the International Space Station. It flew 23 missions between 2010 and 2020 when it was retired. Boeing designed the Starliner to accommodate passengers or a mix of crew and cargo for NASA missions to the International Space Station. It will carry a mix of 4 NASA or international partner astronauts with room for a 5th paying passenger. This is a model of the Artemis Space Launch System. NASA's Artemis campaign involves exploring the moon for scientific discovery, technological advancement, and to learn how to live and work on another world in preparation for human missions to Mars. This is a model of the Delta IV Heavy, an expendable heavy-lift launch vehicle, the largest type of the Delta IV family that made its final flight on April 9, 2024.